Hi, so we're going to look at sample space and simple probability today. We're going to start with sample space because without knowing what sample space is, you really can't go any further in probability. So the set of all possible outcomes is sample space. So an example would be if you were to roll a dice, you would have six outcomes. You could land on a 1, 2, 3, 4, 5, 6. So the sample space of rolling a dice is 6. Let's say in a deck of cards, the sample space of drawing each individual card would be 52 because there are 52 cards in a deck. So you're looking at all possible outcomes. What are all of them? Flipping a coin, there would be 2 sample space size. Your sample space size would be 2 because you could land on heads or tails. Now, there's lots of different ways that you can find your sample space. Some of them, the easier ones, you will just be able to know. You can just count them. But something you can do is obviously make a list. And that's what that first example is talking about. They're giving you all the different combinations of those 3 students to do their presentations at this assembly. So you can just make a list, and that is what this is showing. That's one way to get your sample space. Another way to get your sample space is by making a tree diagram, which is what example 2 right here is talking about. So here, this is showing you a tree diagram for picking an ice cream cone, where you can have a waffle cone or a sugar cone, and your choices are chocolate, mint, or peanut butter ice cream. So if you notice, you start with one of them, either the ice creams or the cones. Here we started with the cones, and then it just kind of spreads out and goes into your different flavors for all your possibles. So either one of these is a great way to make sure you get all of your sample space, even including those ones that you might not know off the top of your head, like rolling a dice or flipping a coin or choosing something out of a deck of cards. Take a look at what this might look like. I've got 2 examples here for us. It says on this first one, Claire is deciding between a red shirt and a blue shirt. The shirt also comes in small, medium, and large sizes. Which diagram shows all possible outcomes of shirts and color size? Alright, so let's take a look at this first one. Letter A, we do start with red and blue, and then it fans out to small, medium, and large, and then small and large. So this would not be my full sample space because this one over here is missing that medium. Let's take a look at letter B. Here we start with red and blue. Again, those are your 2 colors, and then it goes to small, large, medium, large. Well, again, that is not going to be able to give me all my sample space. I'm missing some sizes. Letter C, we've got red and blue, and then it fans out to small, medium, large for each of them. That looks really good. Let's just double check here. On this one, we've got our small, medium, large, and then it fans out to red, blue, and then it just has red. If this one had gone to blue, it would have been great, but it's missing that one. This is giving me all color options and all size options. So our answer here would be C. All right, let's try this next one. Tony's Pizza Parlor offers 3 kinds of toppings and 3 sizes of pizza. Which table shows all possible 1-topping pizzas? All right, so this is an example of where we've got our doing it by a list. All right, so we've got small, medium, large for the pepperoni, small, medium, large for the cheese. Well, it says here that there are 3 toppings, and here I only have 1, 2. So it's not giving me all my toppings. Let's try letter G. All right, I've got small pepperoni, small pepperoni, medium cheese, medium cheese. You guys, on this one, even though they're giving you all the toppings and all the sizes, if you look at the pairing, these are all identical. Okay, so they're not giving you all your choices. Let's try H. We've got a small pepperoni, medium cheese, and large veggie. We do have all the sizes and we do have all the toppings, but we don't have all the possible combinations. So let's try this. Here we've got small pizzas in pepperoni, cheese, veggie, medium in pepperoni, cheese, veggie, and large in pepperoni, cheese, and veggie. That's the one, letter I. That's the one that's giving me all my options, all my sizes, and all my toppings. So that's what sample space looks like. It's by finding all your possible outcomes. Let's take what probability is. Probability is the chance that something will occur. So here in words, the probability of an event is a ratio that compares the number of favorable outcomes to the number of total outcomes. So this bottom number here, that is your sample space that we just talked about. It's all possible outcomes. And then the top number is, well, what are you talking about? Where are those outcomes? So let's take a look at these two quick examples. So we have a dice here. There is a 6 equal likely outcomes. That's your sample space. And we want to find the probability of rolling a 6. So in our outcome, we have 6 possible outcomes, landing on a 1, 2, 3, 4, 5, or 6. Out of those 6, we only have 1 6. So my outcome would be I have a 1 in 6 chance of landing on a 6. All right, let's try this one. Again, I've got 6 outcomes, and we want the probability of rolling a 2, 3, or 4. So I have a probability of landing on 2, 3, and 4. I've got a 3 in 6 probability, and that would simplify down to 1/2. So your top number is the number that it is likely to happen, how many of those there are that could happen, and the bottom number is your number of outcomes. So let's try these last ones real quick here. So number 8. This is our spinner over here, and we've got 1, 2, 3, 4, 5, 6, 7, 8 slices. So 8 is my possible outcomes. And out of those 8, how many of them are blue? Well, 2 of them are blue. So for number 8, I have a 1 in 4 chance of landing on a blue. So the probability of landing on an orange. Well, we do have 8 possible outcomes, and out of those 8 outcomes, 0 of them are orange, so I have a 0 chance of that happening, and that's okay to have a 0 chance. All right, number 10, still have 8 possible outcomes, and we're going to do red or yellow. So we're going to count, I've got 2 reds and 1 yellow, so 3 altogether, and that can't be simplified, so I'm going to leave that. Number 11, I've got 8 possible outcomes, and I'm looking for the probability of landing on a red, yellow, or green. So we're going to count all those. So red, 1, 2, yellow would be 3, and green would be 3 more. That would be 6 out of the 8, which that would simplify to 3/4. Notice I am simplifying every time. Number 12, not brown. All right, so I've got an 8 possible outcomes. Out of those 8, all 8 of them are not brown. So I have a 1 chance, or 8 out of 8, 100% chance I'm going to land on a color that's not brown. And then letter P, not green. So again, 8 possible outcomes. I'm going to count all of the slices on this spinner that are not green. That'd be 1, 2, 3, 4, 5. 5 out of 8, and that cannot simplify. So that is sample space and simple probability. Good luck.